questions as we can. So with that, Philip Perry's been with Jamesway, I think we figure what, 10, 11, 12 years, something like that. But he's been in the hatcheries. He's been in the hatcheries forever. That's the forever part, 30-some years or so. A lot of experience in incubation and incubation systems, from personal experience as a hatchery manager and as a consultant. So he's got some very good information on ventilation. And with that, I will let Philip take over with this, and then at the end we'll address all your questions you might have. So Philip, go ahead.
Okay, well, appreciate everybody turning out today. It seems like we had quite a bit of interest in the ventilation and what it does, the vital fuel for your hatchery. So we're going to go through this particular presentation. Kind of turned out it's not so much troubleshooting as it just a general knowledge of ventilation. I just feel like a lot of times I go into hatcheries and we just don't understand exactly what ventilation does for our hatchery, how it operates, and how to keep it working. So with that, we're going to look at a definition for ventilation is the process by which clean outdoor air is intentionally provided to a space and stale air is removed. That's a good definition for hatcheries, and that's what we see in our hallways and in our throughout the hatchery. The purpose inside of the hatchery is to provide oxygen for metabolism and to dilute or remove metabolic pollutants. The main thing in a hatchery is carbon dioxide and odor. So ventilation is fuel for incubation. No matter the hatchery size or the species being hatched, accurate temperature, humidity, and controlled air ensures the success of hatching. Ventilation is everything done to condition the air. So we're going to take a look at ventilation and how it affects the operation of our incubators and hatcheries. First animation I have here, this is our multi-stage airflow. As you can see, we have air coming in. Let me get my pointer up here. So air enters through the intake of the machine, and it cycles through the machine, and what is expelled, the stale air, comes out the exhaust in. And so we'll be referring to this quite a bit as we go through the presentation. One thing I just want to point out is that we want this air controlled that enters, and we want it controlled as it comes out. If we don't have control, if the room is negative, then the machine has to pull this air, and if the room is over pressurized, then it pushes air through the cabinet, and this really interferes with the distribution of the air. The same way with the air as it exhausts, it just wants air available at its needs, and it just wants to be able to exhaust it. It doesn't want to have any interference with these two, with the intake and exhaust. Now we'll take a look at multi-stage. This is a P80 unit, a dual zone. So we have our intake air comes in through the middle, through the intake duct down and disperses down along the sides where the fans pull the air through and then circulate it within the cabinet. And then we have an exhaust in the front and exhaust in the rear. And then if you have the a P40 or P60 cabinet, you'll only have the one exhaust, which is normally located in the rear. But anyway, again, this machine wants the air available kind of the same way. The fans pull this air in, and then they also exhaust it out. So the cabinet sort of becomes, has its own little pressure system going on. We do not want to force that air down it. It'll mess up our airflow and our temperature throughout the cabinet. Taking a look at the incubation needs for ventilation, optimum conditions for incubation. One is air temperature. The incubator, the hatchers need the proper air temperature. It is a key input to all incubator and hatchers. The temperature outside that machine and that air that it is pulling in. The next is for optimum conditions is fresh air. The incubator needs to be supplied oxygen. The pressure controls the volume of air in the room and how it enters the machine, and CO2 removal. Humidity control. We'll take a look at these and break them down some, but humidity control is humidification, and in recent years I've seen come in the industry, in the hatching industry, is dehumidification. So now we're able to dehumidify that air in the rooms, especially in hotter, moist climates. We can condition that air a lot better now. So all these needs must be met to have an optimum condition, and a lack of balance in one area can influence the others. And we'll take a look at how these interact and can interfere with each other. So a key input, again, is air temperature for all our incubators and hatchers. The cabinet temperature as air is exchanged. So the air that the cabinet pulls in, if it's the correct temperature, then the machine has less amount of cooling and heating that it has to do. So I've always felt like incubators run their best, and we get the best hatches with as little artificial outside inputs coming into the machine. If it can hum along without calling for a lot of heating and for a lot of cooling, and we can condition the air as it comes in, then it just provides the machine runs much better, and our quality of chicks and species are a lot better in hatching. The other thing, the influence of the room temperature is the stability of temperature. We have less cycling. We run a more stable set point that we're running on a machine, and it's less up and down, and just needs to be stable. Humidity control is another thing that room temperature affects the amount of humidity coming on and off inside the machine. So we'll take a look at the influence of room humidity, incubator and hatcher humidity levels, is the spray nozzles. If we have the room air is dry and we're pulling it into the machine, then the nozzles come on more, and it can be disproportionate to the amount of spray that actually is needed. This is a big factor in multi-stage incubation, where the spray of the nozzles is really 70% of the control of that machine. Is the proper spray of the nozzles as it's being dispersing humidity throughout the cabinet. The other thing, very important factor, influence of room humidity, is the moisture loss. Depends on the incubation humidity levels. So if we have low humidity and we can't keep the spray up, or the spray nozzles come on, can affect, we can either too much moisture loss or not enough. So that it is very important. It affects the ability of air to remove heat and moisture from the cabinet. The higher humidity within a cabinet, this can lead to overheating. It just can't, the air can't be removed and can't be cooled down because of all the moisture in the air. Dehumidification, which we touched on, must be done correctly to avoid temperature swings in the room and also in the incubator and hatcher itself. When we talk about this, we're talking with dehumidification is short blasts of heat to the incoming air to dry it out. And if it's not done correctly, we can cause some large temperature swings that will affect the inside of the incubator and hatcher. The influence of room air within the cabinet. We're looking at the developing embryos require oxygen, and the requirements increase as the embryo develops. It goes up exponentially. Turkeys, from about 20 days of incubation on, they are sucking in oxygen. And chickens, we're looking at about 14 days on is when they really become, really require the oxygen. The respiration releases water, vapor, and CO2, and this is another thing that increases, and it needs to be removed through air exchange. the room supply and exhaust plenum pressures influences the airflow through the incubator or hatcher, which we touched on. It ensures that adequate oxygen is present, contributes to cooling. It removes water vapor and CO2, and it distributes the air uniformly if correct, and it causes hot and cold spots if not. So a lot of times I'll visit hatcheries that may have an overheating problem, which may be a factor, either room temperature or it could be their chilled water temperature, but they crank up room pressure, and this actually, you think the machine is running cooler, but because we're running air faster through the machine, there's less mixing, and it often, the air just isn't distributed uniformly. So again, the influence of the room air can cause all these things, and it just needs to be correct. So the machine picks up the air it needs, and it releases the stale air that it needs to exhaust. The cleaner the air, the better. So now I want to take a look at types of heating ventilation equipment. One is the standard, the rooftop unit. It's predominantly in America. In the U.S., most air handlers are rooftop units, and then now we're seeing more and more air handling units coming on to hatcheries. They are becoming more popular. SoTech has a unit. Just a lot of companies are using more and more of these, and now Jamesway has a line. So we'll be talking a little bit about that as we go in more into the presentation. But these are mostly what we would call just on and off type units. They have 1 to 2 stages of cooling or heating, just cycling on and off. And the air handling units have a modulating fan, and we'll discuss that a little bit more as we look through the presentation. So taking a look at, first thing we'll look at is rooftop ventilation. I'm sure a lot of you are familiar with this, and this is how it works. It operates as a constant volume system. This means that the fans blow recycled air mixed with fresh air. The fan is a constant speed, and we're changing the mixture of the air being dispersed into the room, but it ducts down straight down into the room or corridor and disperses out through the room, and a return duct is installed to bring this unused air back to be recycled. So we have a little animation here. Recirculated air mixed with clean air is blown down into the corridor. So it disperses out through the corridor, and then here we see the machine picking up this air as needed. If it doesn't need it, then it's just pulled back up, it's recycled. And air that has not entered the incubator was just pulled back up through, recycled into the rooftop unit, and then dispersed back out. So pretty simple system. It is for cleanliness. Again, you take a look, you see the word recycled. So if there is contaminants in the room, we can potentially contaminate our ventilation system because of the recycled air being pulled back up through. Here's a diagram for looking at how the room pressure works with a rooftop unit. This particular unit, we would have a total of 5,000 CFM being dispersed through the fan. But to come up with this total cubic feet of air, we're having 4,000 pulled back up, recycled through the room, and 1,000 is introduced as fresh air. So what this does, it's a mixture of 25% outside, 75%, gives us a total mixture of 100% air being dropped into the room. But at the same time, part of this is recirculating. The pressure in the room is controlled by modifying the amount of outside air to recirculated air in the room. If the pressure would drop in this room, we would add more outside air, and this damper would close down, bringing the pressure level up in the room. Taking a look here, the damper adjusts to meet the pressure requirements. They work together, and as the pressure in the room is monitored, the set of dampers will control the pressure. This is a train rooftop example here. Pressure settings vary with machine type and size of the pressure that we want in the room. But as the damper system, as it shows with air returns, the linkage modulates. So the dampers work oppositely, so that when one closes, the other one opens. And it's essential that the room, it's referenced to the outside, but it's essential that that a room is well sealed to prevent issues maintaining pressure. Doors should always be kept shut when not in use and should not be propped open in the hallway. But this is how this adjusts to the set point of the room. If we're wanting more, if the room becomes overpressurized, we'll bring in more recirculated air, and then recycled, and then outside air comes in. So this is how the room pressure works for an RTU rooftop unit. When we take a look at 100% fresh air ventilation, we'll take a look at how this system works. It operates as a variable volume system. This means that there's no air recirculation. The air is modulated with a fan. The airflow, humidity, the room pressure, the warm and chilled water circulation is all controlled by one unit. And the room pressure, again, is controlled by the VSD or fan modulation. Here we have an animation that shows the VSD fan modulates the air supplies to change the pressure in the room. So it either speeds up or slows down. And this is referenced to the outside. So the air supply to the room, the incubator, as the intake opens, the pressure in the room would drop, and the fan would speed up and add more air into the room to keep the pressure, whatever our set point is. And then as it circulates through the incubator, it is exhausted into the plenum. So just a simple diagram of how the fan modulates the total volume of air it supplies to change the pressure in the room. Here's a example, just air being dispersed. There's no recirculation of the air. Machine is pulling into the intake what it needs, and again, it's being expelled. The stale air is being removed into the plenum. So very good for, like I say, to keep a clean environment, and there's not as any introduction of any contaminants that one machine might have. You run less risk of introducing it to other machines in the hallway because the air is not being recycled. Sensors for control. So these machines have to be, we have to take a look at how we're going to control our temperature, our humidity, and our pressure sensors. This is just a typical sensor pack that we would have located in the room. It needs to be in a well-mixed airstream, and usually at least a meter from the return air. So we got our humidistat here, measuring humidity, controlling our nozzle, our spray to come on and off as the room needs humidification. Have a picture of our temperature probe. RTD controls the temperature of the room. We have a Cetra pressure controller controlling the pressure of the room. So we don't want this, we want it up in the airstream in a well-mixed area of the hallway, protected from direct influence by any other HVAC equipment in the room. A main concern here is the humidification spray. If it's spraying on an RTD probe, causes evaporative cooling, causes a lot of cycling within the room. It can also affect our humidity, comes on and off. So again, we want to have it away from anything that might cause it to not read properly or to be over what it would do to certain conditions of the room. Here's a slide that just shows one up in a area that's away from anything that would interfere with the monitoring of the room and the control. located in the room, not in a corner where a microclimate can develop. So again, here's another picture of one in a hallway, away from, centered in the hallway, away from humidification, close to return air, high in the mixed air stream. So this is a picture that shows a proper placed unit. If you'll notice, this is some of our Platinum P1s. We considered when we were putting this presentation together showing more of our modern equipment, but you know, a lot of hatcheries will run equipment for several years. So it's very important that this part of the equation for making sure that the fuel, the ventilation is proper, not only for our more newer machines, but our older machines. To get the most out of these and our multi-stage machines, we need to have this, our control monitoring situated in an area of the room that will always give these the best supply that they need for the air. Some of the humidification options for either ventilation equipment that we use is the Bonson type humidification system, and also one that Jamesway carries is the high pressure humidification system. So these two types are what we mostly see in the field, and they're just controlled mainly by an on and off control signal. Bonson is the more traditional type, and it's used in a lot of the smaller hatcheries, has a lower cost, but it does have require quite a bit of maintenance. It can be a reservoir for bacteria, so it just takes, has some concerns. A lot of hatcheries are going to a more high pressure system. It's 1200 PSI, and it provides a much finer mist. You don't have any floor wetting as long as it's has ample ceiling height, no wet spots on the floor, and very good system, very reliable, and a lot of hatcheries are moving to this, both in multi-stage and in single stage. Other options is steam humidification. My experience with these and have been, they just require a lot of maintenance. I had a lot of trouble with hard water and a lot of lime, calcium, just mineral buildup of these, and just for my application, when I've used them, they've been difficult to use, but I know a lot of hatcheries use them and are quite happy with them. And some of the older types, and they're still used, are air and water combo nozzles, usually located around where the air is dispersed into the room. Again, it is a combo. I go into a lot of hatcheries. I see air, when it's calling for humidity, I see air blowing or hear air blowing, but I don't see any water. Or I'll see the air not working and water just coming out in just pouring out into the floor. So again, a good combination, works well when it works. Typically have a reservoir, so but again, I think some of the more modern hatcheries and applications that you know, feel that would help you the most is this high pressure system. Works well in dry climates, in the northern climates when the air gets very dry. In the wintertime, very good system to use. Another part of our control system is our outside air reference. This is where we locate the reference to the room for our room pressure, usually references to the outside. This needs to be mounted on the roof, usually 12 inches above surrounding obstacles. Take a look here. This is how it usually is set up. It comes up through a conduit, and then this reference, what we call a reference sensor, is attached to the top of the conduit, and then the plastic tubing is connected to the inside of this sensor. And the other, it should have no physical or mechanical obstruction. It's not mounted under awnings or other projections within 15 feet. So we want a true reference when we're referencing to the outside, and we're just trying to take away anything that could interfere with it doing the proper monitoring and providing the proper pressure within the room. It's often mounted on a rooftop unit, and sometimes it's necessary to move one around once you have one to find an ideal location on the roof for it, especially if you have a windy location. And the ideal is unobstructed view of the horizon. So just to get it up there, I just want to mention, sometimes I'll go to hatcheries that we feel like the pressure is not being monitored correctly. So when we examine these, sometimes insects, spiders can get inside and build a little nest in there. And so it's good whenever you're doing periodic maintenance, preventive maintenance, is to check these for any type of that thing that may be stopping it up or being able to measure air properly. Another thing is moisture in the wintertime can collect in these, especially when the tubing goes up through your plenum area and on up into the roof, that warm air, and then as it goes into the outside air, can collect moisture, and sometimes you just have to blow the air out of it, or blow the moisture out of them a couple times just to keep them free so that they're measuring properly. And so now we'll take a look at the pressure control. We've looked at the air control for the room. We're now going to take a look at our the plenum pressure. And so this is controlled with a sensing tube in the plenum, either referenced into the, normally referenced to the room. And so we have the a slightly negative area in here. Exhaust plenums for both incubator and hatchers need to be pressure controlled, and the variable speed fans are used to control this. They modulate and increase or decrease the amount of air that they are extracting from the plenum. Here we have the tops of some incubators, and as the air disperses into this plenum area, this is your extracting fan that either is controlled, modulates either up or down as needed. The plenum is maintained at a slightly negative pressure, a slight vacuum to ensure that the air flows through the machine from the hull, from the intake of the machine and out the exhaust. Plenum pressure settings vary with your machine type and size. These are in your operation manuals, and you should know what your requirements are for your machine. And one thing about the plenum, this can be referenced to a machine hallway, but these can also be referenced to the outside. One of the instances when we would reference the plenum to the outside is if you have two separate incubator hallways, but are sharing the same plenum. So if one hallway has its own rooftop unit, its own air supply, independent from the other incubation hallway, but they're sharing the same plenum, then when this would happen, you would want to reference into reference to the outside, so that if we're referencing the one hallway, but we have two hallways sharing the plenum, it might overcompensate or undercompensate for the other room. So this is when we would reference to the outside our plenum pressure sensor. Here we have a picture of a hatcher plenum. Have one fan extracting the air out of the plenum area. These are some P30s or P20s, and these just have a damper system. They don't have the fan. So as the air is being moved through the hatcher, as it just is pulled into here, this fan will extract that air, and it modulates depending on the amount of stale air being dumped into the plenum area. Here we have a P40 or a P30. Now we're making these available, these fans, for the exhaust system. But as this air is exhausted into the room, we have one fan picking it up. This is usually right after transfer. There's not as much air being dispersed. And then as we ramp up and as our hatch nears completion and we want to dry our chicks' poults out, we'll ramp the ventilation up to 100%. This is moving air through the machine, and the second fan can kick on and allow to make sure that we have plenty of air removal for the area. Our engineers usually like to spec these out at least 20% more than we would be dispersing in here, just to make sure we always have the proper amount of coverage to remove the stale air. And also we have plenty of room air coming in as well to keep the proper flow across the cabinet and remove the air. As we give more air to the unit, more air needs to be extracted. Here's just a plenum pressure measurement, just a guideline. It's very important to ensure you know whether the plenum pressure measurements will be referenced to the room or to the outside of the building or the 0 point. And so as you can see in this illustration, achieve the same differential pressure across the machine in this situation. The set point is half that when referenced to the outside. So if you reference to the outside, you just need to set a negative set point that is a total difference minus your room pressure. In this case, if our desired is an 0.4 negative across the room, across the machine, we would subtract our 0.2 would mean a negative 0.2 plenum set point. And if you reference the room, then you would want the 0.4. So this is how you calculate how you want to run your plenum, whether you're running it, referencing it to the machine hallway or referencing it to the outside, to the room, to the outside and to the room. In the multi-stage plenum, it's normally the stale air from the multi-stage incubator exhausts directly to the outside atmosphere through an exhaust in the rear roof. So with a if you got a 16-foot minimum roof, then it's not necessarily to have a plenum area with a controlled exhaust fan. It's equally feasible to connect the machines to a common powered exhaust, but again, it's not necessary as long as we don't go over 16-foot ceiling to get the air. The machine will remove the stale air itself. We just want to make sure that our supply area has the proper supply of air in the room itself. The exhaust plenum reference, it's usually in the main airspace in the plenum area for incubators. For hatchers, we want it at the opposite end from the fans where the exhaust, where it's exhausted out. And we normally either that or in the center of the plenum or between two machines. We just want it should not be located near the exhaust fan, but instead centered between two machines. We just don't want any interference with that air so that it doesn't blow directly on our reference tubing, and just kind of in a centralized location, not affected by any other thing that could be blowing or interfering with the measurement of the pressure. Fresh air requirements for the incubator and hatch rooms are not consistent, but are dependable on variable factors. So it's just kind of like a continual moving target, or we would just have a manual setting for our ventilation, and we would just leave it like that and go away with it. Some of the older machines, I know the Peterson machines, they had like a raised hood that would collect exhaust, and but it would also pull in outside air. And so we had different ways of doing, of extracting that air. But now with the damper systems that we use, things like that, there are many things that can influence the amount of air and how we handle it. One thing is the stage of incubation or hatching, and this would refer to the damper openings. As dampers open up, more air is required for the machine, and more air is being exhausted. So we need to make sure that we have coverage for the minimum and maximum settings of the machine. Activity in the room is another thing that changes our target or what air is being supplied into the room. When we set eggs, we prop doors open, move them in. We're affecting other machines that are in incubation. Transfer, pulling eggs out of rooms. Again, these are activities that affect our control of our ventilation within the cabinet. Hatching, this is a main thing I see a lot of times. If you're pulling a hatcher, the doors sometimes are propped open to that room to move it out into the hall. And this is affecting other hatchers in the room that are still needing a fresh air supply, but we just dumped all our fresh air out into the hallway. So again, once you get your hatch baskets out, you know, we need to keep the doors closed so that we can keep a even flow of air, and the machines that are still in the hatching process have their air needs met. Cleaning. A lot of times we had to turn our hatcher rooms around in the same day. We had to remove, get our chicks out. Often, you know, it's just the way logistics work. We have to start cleaning when that first machine is removed. Again, we want to start our cleaning process, usually down the hall, away from the door. Start with that machine first, working our way back down the hall. But as a hatcher is cleaned, we need to close the dampers up so that the air is not being taken away from our other machines that need that air at that particular time. Another thing that affects our fresh air requirements is the activity in adjacent rooms. I've gone into hatcheries, especially hatch rooms, see a hatch room go negative, and come to find out that the washroom exhaust fans were turned on, and there was no makeup air for the washroom. And so what was taking place was that the air from the adjacent room, the hatcher room, was being sucked out and taken out through these massive exhaust fans. I see this quite often, and you can sometimes see this just in machine behavior, either overheating or humidity levels get high, different things like that. But again, these are all things that affect the pressure of our room, and we just need to be aware of it, how often the doors are open, and things that can interfere with our air that we're providing to that room. So when we think of controlling the heating, ventilation, air conditioning, so with so many variable factors, hatcheries need a control system to automatically detect these changes and adjust the fuel mixture. Our fuel mixture being our temperature, humidity, and pressure. So looking at control and monitoring ventilation, the controls design needs to be designed for a hatchery. Back in the old days, there wasn't companies like Jamesway that provided these, and we saw the need. Hatchery planning is another one. You know, there are designs. These are designed for a hatchery. It's not so much for an industrial type of controllers, which is often what we used to have to use because that was all that was available. But now companies have come up with designs that are specifically designed for hatcheries. We need programmable PLCs based on the system. In-house design, you know, with environment in mind. The equipment is designed to be water resistant and flexible and capable to control most commercially available HVAC equipment. So not only does the control maybe fit one company and the units that it uses, but we also need to be able to control whether it be Train, Aeon units, various Linux, whatever, different units that whatever we're using to use in our rooms. We need controls that monitor alarms and collects data. Take a look here. This is a Hatchcom 4 screen I have here. Picture of an incubator room. Looks very familiar to our Platinum screen on our machines. It's kind of designed that way so our Platinum users would be familiar with it. Here we have our temperature, and our set point is 78 degrees. The actual is in the yellow box, and we're running a 77.5 temperature right now. And so our stage 1 heating is being shown. It is calling for heat. Again, real time, we see what's going on in the room. Then we have our pressure settings. This room is set at a 0.01 inches water column. We're running on set point. Our damper opening is showing is at 30%. So this, all these things kind of just give us a glance of what's happening within the room and what the parameters are. You know, useful tool if you come in and you saw you were running low here and your damper was running 100%, you would probably, for troubleshooting, you would go see what, you know, is this damper actually at 100% or why I'm not maintaining my pressure value. A lot of these controls now, with this control, we have a schedule. So chick service rooms, rooms that aren't being used all the time can be programmed to have heat when it's needed. And then when it's not being used, the room, we can also schedule it. A lot of people use these for hatch rooms and hatch plenums. Once rooms are cleaned and dried out, they'll just schedule it to either shut the ventilation down or at least use much lower settings to make it more efficient. We have alarm settings that would tell us if the room is overheating or if it's getting too hot or not getting, if it's running cold. Different alarm settings. We can graph these out and take a look at some of the what's been happening if we're having a lot of heat activity, more than normal. Maybe we have stage 1 heating out and stage 2 is staying on all the time. So just a lot of different monitoring and availability here to you know, have an analysis of the data that it collects and to keep the hatchery running smooth. Just talk a little bit about our Jamesway Guardian. Again, we're talking about controls designed for the hatchery. This controls up to 4 rooms and 4 plenums per panel. It's modular, expandable. It again is PLC-based system, and these systems are they're flexible and capable to control most commercially available HVAC equipment. So if you have equipment now that's not being controlled, you know, please consider the Guardian. It is interfaced with our Jamesway Hatchcom 4. And a very informational tool that can tell us, you know, what's happening within the room. Designed specifically for hatcheries, and these again can be used with most available HVAC equipment. Moving along, I'm not going to go through these or spend a lot of time on these, but we have Optimum incubation room conditions. These are all located in your manuals. That you can, in your operation manuals of the various set points that are recommended and required for a lot of our machines. And just point out that multi-stage differs a little bit because multiple-stage machines have a lot warmer and higher humidity environment to operate properly. Usually on room pressure differential, if the guideline says an 0.05 to 0.15, I'll split the difference to start with. And then if I have some issues where they might either require more air movement, then I'll tend to move it up and use the more of a maximum setting to use. So this is our incubator. These are some of the hatch room conditions, very similar to our incubator. As we get larger, our larger P40 hatcher requires more air to be moved through it. Multi-stage hatchers, now that people are using more and more of a profile in our multi-stage hatchers, as hatches complete, we're needing to ramp up our exhaust fans and move us on up to an 0.15 pressure in our plenums, and to get more airflow and into the hallway. Also, looking back at the programmable features, when you have a control system, we can drop the room temperature for the stage of hatcher that the evening before, if our hatch is becoming complete, we want to start dropping temperature. We don't have to manually change the temperature. We can have a schedule that will automatically drop the temperature in the room. Again, here's Optimum Plenum conditions for our Platinum series, for our various incubators, and as we get larger, they need more airflow removed from the machine, and then in our hatcher exhaust, our plenum requirements for them. These are all in your operations manual, and if you can use them for your reference and as a guideline. If you have questions, you can contact us. We haven't really touched on a lot of our machines and the maintenance of our ventilation equipment, but there are some essential maintenances I just want to touch on. One is filter changes. Of course, you should be doing this, but for every hatch, for the hatcher room, pole and chick room, anytime we have put birds and been exposed in these rooms, then we need to change the filters. And then at least monthly for all other areas. We just need to have a good maintenance program for that. A lot of times you can have a contract service provide filters, which can have some microbial control, and they can also do some of our rooftop changes for us, and to make sure that these are being changed on time. Need to check on our belt-driven rooftop units, our squirrel cage fans. Need to check our belts monthly, make sure there's no slippage. I went to one hatchery that couldn't keep up, couldn't build room pressure. And again, the controls said that, it was, dampers were open 100%, but yet it couldn't build. When we went up and examined it, the belt was slipping on the squirrel cage. So even though it was saying it was running 100%, had 100% dampers, it still could not pull enough air through the cabinet and pressurize the room. We adjusted the belt, and it came right up, and was able to get the pressure of the room where it needed to be. We recommend service checkups by licensed technicians, usually 2 times per year, spring and fall, when we're changing seasons, when we're going into a heating season or going into our cooling season. It's good to have these checked then, and also check our damper positions on our RTU units. Make sure that they're operating linkage and haven't gotten out of calibration. The other thing about having a rooftop ventilation service, often you can have a contract with them to where they're available 24/7, so that if you have a rooftop unit go down, not only can they be performing checkups on your room, but often they'll give you discounts on parts, things like that have to be used in case you have a late night unit go down. Call them in, and they'll get the unit up and running for you. And again, we need to service as recommended by the manufacturer, and we need to check our sensor calibration at least twice a year. Some people like to do this monthly. The sensor calibration would be our pressure control sensor, our humidity, and our temperature. Again, we need to check these ever so often to make sure that they are running where they need to be and adjusted if need be. So I was talking to a couple of engineers about the life expectancy of our heating ventilation units. Ventilation type equipment typically lasts 20 to 25 years, and that's when it's well maintained. And it usually becomes easier to replace units rather than replace parts. A lot of times the gas heat exchanger, if you're using gas, the heat seems to be a weak point. I have gone through that to where we put have exchanged the gas coils, had to call a crane in and replace that exchanger, dismantle the whole unit. Took a couple of days to do. Again, it's the same for the evaporator, condenser coils. They develop leaks. So at that time, it just becomes much easier to replace the unit rather than repair it. Control systems can become outdated, but often they are, they just add additional programming and features that, that weren't thought of with the original concept of the controller, but we can add modules to our Guardian system to keep these things, more in tune with changes that we are doing. So they can become outdated. Maybe you need a new control system, but often they can be updated. RTU, RIP. So I wanted to just share some of the ventilation equipment that Jamesway has to offer. Of course, we have a customized ventilation shop, and we have extensive experience with ventilation, and we have expert design and support for our new airway system. Taking a look here, this is the Airway Classic. It's a customized rooftop unit, provides the perfect environment for each room. Every hatchery requires its own unique ventilation equipment. So these can be designed by our hatchery engineering team and to get the correct equipment. I visit a lot of hatcheries that are either undersized or oversized for their heating and ventilation needs. So a lot of times an industrial type engineer for air systems may be consulted that doesn't all the time really understand what goes on in a hatchery. So it's good to have an hatchery engineering design the system that you need. Another one of our packaged systems is the Airway Element. We're very excited about this, designed for easy installation, and it's for the most efficient and effective hatcheries. So these are typically 100% air handling units, and you can just, and they're not necessarily located in the hatchery, but it's a packaged mechanical room, and it's located on a pad outside the building, and it frees up floor space within your hatchery. So it has some redundancy. When we say that, it has extra fans, different things that if you would have a mechanical breakdown, you can get this service as well, so that if you have a boiler go out or whatever, we can keep the unit running while we get one replaced. The other is our modular airway. It's a flexible and expandable approach. Again, it's 100 fresh air with chilled water cooling. Can also provide dehumidification and heating as required. Again, here's a illustration of redundancy. 2 fans for our variable speed 100% fresh air. So if one fan would go out, we always have a backup unit. Again, these are great units, and hope you have an opportunity to visit either our website or talk with one of our salesmen about looking into one of these units. Again, with the airway system plus the Guardian HVAC plus Hatchcom 4, this would equal fuel for your hatchery. This gives you your entire hatchery at your fingertips. You can see what your machines are doing, what your hatchers are doing, and then we also have our incubator room. We can see the ventilation in our layouts, and also see our plenum. So just a demo illustration here, but again, as management becomes more and more tied down to their office, it does give you some monitoring capabilities by having this, and it gives your hatchery at your fingertips. So in sort of summing up, ventilation is the vital fuel for your hatchery. Optimum HVAC conditions increases the flexibility and the response of your machine operation. It reduces the number of causes of bad hatches, increases hatchability and chick quality. Other improvements are indicators outside of the hatchery. You see improvements in first week mortality and overall health of the chick. So again, it's the vital fuel for your hatchery. So with that, we're going to turn this back over to our moderator, Keith. And so
All right.
let me get here.
Thank you, Philip. A lot of tremendous information there, and you can tell a lot of experience that Philip has in this area in a number of different avenues, having been in a lot of hatcheries of different styles and designs and whatnot. Okay, we've had quite a few questions here, and just to remind those in attendance, because several people did add late, and I'm glad you were able to join with us when you could. Post your questions down in the Q&A box down on the bottom, type them out, and we'll address what we can right here. Okay, I have several different questions on here and kind of lump several of them together to get a common answer for them. In referencing your pressures, there's been several questions about referencing them to inside air, to maybe ceiling, to outside air, maybe to ground pressure outside, different things. Can you talk about what options are? One question specifically for ceiling, not outside. I mean, what are the difference between the two, and how do you go about that?
So we have, when we talk about in the room referencing, we want to know what the pressure of that room is compared to the outside. So when we look at the reference module that, we call it a sensor that we would put our tubing in, it needs to be typically high up within the air, within the room, that an area that is receiving air mixing within that room, but we don't want it interfered with any influence of the humidity spraying on it or anything directly like that. And then the other reference point, when we reference that inside air to the outside, would be the reference sensor where we would locate it on the outside. So and when we review that, it needs to be high up outside where it's not interfere with where any what we would call anomalies of the building that would disrupt the airflow pattern flowing over the building and maybe interfere with the sensor. So that is why even though I've seen hatcheries put their sensor down over the back side of the hatchery out of the airflow, it's not, there's an anomaly of the building being created around that sensor, so that we have to get it high up in a way. I've also, again, these are probably questions for our engineers, but I have heard of people burying some of these outside just because the air is so tremendous out there, which affects the reading of the sensor. And so a lot of times control systems take into account the fluctuation of that reading and averages it out and then controls the room that way. So I hope I answered that question.
So there's ways to do it each way, but you're trying to get to the same point, in other words. And
Right.
you mentioned the ground pressure, and that was one specific question that somebody had, that hospitals do that, and then some hatcheries are doing that. And basically that's another way to remove that variation that you might get from wind, correct?
Right. That is correct.
And I think that is important. We've seen that, you've seen that, and I've seen that, where you've had hatcheries where they have disturbances from wind and weather, and they've got to be creative and figuring out how to do that.
Lost you.
Okay. Am I here?
Seem to be having some technical.
Philip, are you there? Okay. Hopefully Philip will join us here quickly.
Typical.
Okay.
There we go.
Are you there? Okay. All right. I wasn't sure whether that was you or me. Okay. Is there a ventilation system type that would be different or recommended for maybe a multi-stage or single stage, or is it pretty much the system itself similar, but maybe how the parameters are different?
That's a very good question. I know that our single stage systems are definitely being used with the air handling units that provide 100% outside air. I'm not so, I don't know if I've seen multi-stage, any that have used that type of air handling system. It's always been return air. Again, that is a good question. Probably leave that. We might have to answer that later, Keith. Talk to some of our engineers just to see. Again, I've never seen that, but that is an excellent question.
Okay. So yeah, that's one that we can maybe address in text later. Do you know, is there, in places with high humidity environments like Gulf countries and things like that, is there differences that you would recommend, or have you seen work as far as ventilation to make our machines work better in like places with high humidity, higher temperatures?
Well, as I mentioned in the presentation, there is dehumidification available now for these hot, humid climates. And the way it works is with a control system, whether it be Jamesway, Sotec, or any of the other companies. And what this does is short bursts of heat to dry the incoming air out. So we can keep that high humidity at a minimum and be able to allow the control of the humidity in the room. So that is one way that I'm seeing it.
And what about in places that high altitude? What would be the options there?
Well, again, with high altitude, there's been a lot of where we look at adding, more oxygen. But again, I think with our experience with our Plenum machines in high altitude, as long as the CO2 set points are made, we typically the machine operates with the proper amount of oxygen that it needs. Now you can inject oxygen at higher altitudes, but that's typically done within the machine itself. It's not part of the ventilation package from what I've seen.
Okay. Question from somebody that obviously is looking at possibly doing some upgrades to their ventilation system, and as other customers might realize they need that. If you had a choice in a hatchery to start working on improving your ventilation system in multi-stage machines on the hatcher or setter side, which do you think would be more important to start really making improvements if you had to choose one over the other first?
I guess it would depend on what I had to work with. If I felt like I could limp along on one system, then I would definitely work on the other. We've seen some tremendous improvements with multi-stage hatching and the quality of chicks, being able to cool the room down, allowing us to cool our hatchers down, and opening up our vents more, especially for completion of hatch for the quality of the chick. I feel like if I had a hatchery and I could get by with the incubator side until I could get improvement there, I would work on the hatching side, just simply so we could make those chicks as comfortable as we could.
Right. Yeah, you've got chicks ready to go at that point.
Yeah.
Okay, this come up several different questions in discussion, and I know you mentioned it several times in your presentation, but again, we're seeing that How much of an effect does the air pressure in your plenums or your hallways affect your actual ventilation in your machines? I mean, you talked about this, we've talked about it, but can you kind of give some examples of some really what can happen if we really don't keep control of this?
Well, a couple of things I've noticed is from hatch to hatch, maybe have a real good hatch, and then the next hatch may go down. A lot of times, it's difficult to tell when everything's the same that out of appearance appears to be the same. A lot of times, this can be tracked back to ventilation. Either it's not being it's saying everything's okay, but it's not. And so that's when we have to go in and start investigating what is out of balance. Hot spots, cold spots within machines. We have hatching, have early hatching. We'll often see damages right before transfer, 18 days, if it's on the incubator, that have overheated, that haven't ventilated properly. Just haven't exhausted the air properly. I have also seen where if we're trying to manage the temperature of our machine by overventilating, we definitely create hot and cold spots. The machine may appear to be running normal temperature-wise, but at the same time, we're just sucking air straight through that machine, bypassing, mixing within the cabinet, hitting our temperature probe, saying everything's okay, but at the same time, creating these microclimates all over our hatchery.
Yeah, and we see that those microclimates a lot with improper pressures in hull or plenums too. And the other thing, our machines, they try to create the environment that we tell it to,
Yeah.
but the more we let our pressures incoming and outgoing get out of whack, the harder the machines work. And they will try to do their job, but they can't do it very efficiently, especially if we put a lot of demands on them from a full egg pack or whatever.
That's correct. Yep.
We've had an interesting question here, and just kind of let you comment on this briefly. If people are using humidifiers in their corridors, have you heard or is it possible to use any sort of disinfection in that humidification system to help in the hatchery sanitation?
That's a good point. I know in my own experience, it always seemed to affect the nozzles and some of its operation. But I know that, if you have a reservoir system, sure, you could occasionally run disinfectant through it, but I don't know of anybody that uses that. I'm thinking right offhand, maybe you can help me with that. I don't see that very often.
Yeah, and there's a follow-up question maybe you can add to that discussion, is that people that are using formaldehyde or other chemicals in their hatchery, have you seen that cause any premature failures or limitations in our HVAC equipment? And maybe that goes along with, you start adding disinfections and stuff to systems, you might have some problems with nozzles. For formaldehyde, for instance, have you seen that affect our ventilation system?
Not too much. Usually formaldehyde is introduced into the exhaust side. Normally not introduced into the room air, but it's usually either dispersed in the cabinet itself, or it's where it is pulled out by the exhaust and out. So I typically don't see any of that. Now, I have seen high levels of peroxide prematurely cause rooftop units to fail. I mean, it just anything. It's very corrosive, and if it gets on your heat exchangers in massive high quantities, it does affect our ventilation equipment.
Okay, here's a question. I know you discussed this a little bit in here. For single stage equipment primarily, do you need fresh air instead of return air, or can you use return air? I mean, you talked about this, and what's your experience?
As long as the return air is efficient. I mean, it does, we're recycling the air, so we don't have to, temper that air at 100% coming into the room. But as long as we have our pressure of that room maintained, then either one functions. It supplies the correct amount of oxygen because we're pressurizing it compared to the outside. Either one, both works well.
Okay, what can be some signs of, say, the outside pressure sensor fails and it's on the outside and you don't really recognize it right away? What are some of the consequences you might see, or a hatchery manager might look for and suspect that?
One would be the behavior of the machine. Is it cycling, calling for heat all the time? Because the room's running too cool. Another thing is pressures, which we kind of talked on. Sometimes our sensors become clogged up, and we'll walk by a incubator hall and the doors are blowed open. That would tell you that something isn't being interpreted correctly by our control system and dumping in all this outside air for some odd reason, and blows doors out. And I've also walked by rooms and seen the doors pulled inward, where the room is running so negative that the incubators have to pull air in from outside in the hallway. So these are examples of whenever we see disruptive in the airflow pattern of the room.
So kind of knowing what's normal and what it should look like, and having the same people do your rounds and routines, and you see something that's off, says, I wonder why this is happening this way. And I would suspect that maybe some periodic checks of the pressure in relation to other areas, just to see.
Right. Another reference point that I use in multi-stage, if you have the HatchCom, you can do a numeric report or even a graph on the amount of humidity, how often the spray is calling for spray. Sometimes I can look at a machine hallway and the spray maybe is coming on 20% of the time, which can be normal, 20 to 30%. And then I'll look at another room and it's calling for 50, 60%, where the spray is being called more spray. That can be another tool. Machine behavior, what the machines are doing to keep the process going.
Okay. The other good question that you mentioned, you've seen it quite a bit, and I've seen it myself quite a few times too, is problems when people are starting to pull a hatch and they want to get cleaning the hatchers real quick. So what would be your process that you would recommend to go through so you don't rob, like as you said, the chicks in the hatchers that still need that air, that are going to be in there for a little bit more time? What would the process be that if somebody we got to get these machines cleaned and they start in a hallway? I mean,
yeah. Well, typically I would advise that I would start with the hatcher that is the furthest distance away from the door. So we would clean that one first, get our chicks out and pull it down the hall, and then we can start cleaning that hatcher so that we're not bringing that fluff and dust by ones if we did it further down the hall. The other thing is once that machine is clean, is to close the dampers 100%. If the damper is open and we shut the doors, then because that machine would typically be closer to our exhaust fan in our plenum area, we're going to rob air from the other machines. So the other thing would be to close the damper down. And I have seen people that have the fan in the back have a cover they'll temporarily put over the fan to prevent robbing air from other machines. That's a couple of things that I would advise. Yeah.
This is a pretty common thing that I see, and you mentioned it as well.
Yeah.
You start pulling that off, and you got your doors open, you got the vent, and your whole damper is not.
Yes.
Right. In your, let me get back to this. Got quite a few questions here, trying to get to some that will answer a lot of different other people's questions. In your visits you've made in hatcheries and your experience as a hatchery manager, what are some good methods that you've seen to avoid outside environmental contamination from your hatcher plenum exhaust?
One is location. I have seen, some, if the hatchery was designed to where the exhaust was in the prevailing wind, I've seen hatcheries go back in and just duck that thing for miles across the top of the hatchery and get it to the side that's unopposing wind, so that it is dispersed throughout. That seems to be one thing I've seen. I've seen hatcheries dump hatcher exhaust into a barrel of water so that, or into a some sort of collection place with water, so that the fluff and contaminants coming out just goes into the water. Again, this sort of creates a reservoir for other things to breed in, but it is one of the methods I've seen to prevent that from getting back into our air intake.
Yeah, we don't want it to come backwards and back in.
Yeah.
The other question, somebody has experience doing this in their HVAC rooms. That was required by the incubators. They use larger systems with the idea of maybe there'll be some expansion down the road. Is that going to have any effect as long as you keep your halls and plenums and everything the pressures they want, have an HVAC system that's designed for more than what your machines require?
Yes, that could, you know, I don't see any problem with that as long as you control the room. You know, I have seen some that have a massive amount of overventilation, and this is caused by just poor design at the time. But you know, one thing I'm thinking about, Dr. Bramwell, is our modular systems. You know, maybe this would be a modular a case for a modular system, to where you could install the system you need now, and then be able to update that system as you increase the capacity, and just add on to it as needed.
So probably add on to it as needed rather than start off with.
Right, just a couple of you know, that modulating the modulated that we had, the modules, you just add on as needed.
Okay. We don't see this too often, but you know, it's possible we could, and I've seen it some, but again, it's not that common. But a hatchery, instead of having all single stage or all multi-stage, if a hatchery has both in the same hallway, so they've kind of expanded, they've done a new single stage and have existing multi-stage.
Mm-hmm.
As far as your hallway and plenum pressures, what do you give preference for as far as managing the machine
typically, my couple experiences, we have hatcheries like that right now, and they typically run an 0.15 pressure in the hallway. This meets both machine requirements, and it's a little high on the multi-stage side, but they adjust their incubation for that on their multi-stage. And then, you know, if you run somewhere, both machines, you can run both of our Platinum like that. And then the Platinum machine, as far as it has a plenum for the exhaust, which is independent of the multi-stage. In this particular instance, that I'm thinking about, the multi-stage is just exhausted out the roof, kind of like I showed in the presentation, and the single stage has its own plenum. So yes, they're both sharing the fresh air in their hallway, and we can do that, but then we have separate exhausts for those.
So that's preferable to try and do separate exhausts for those.
Right.
Okay, you talked about this a couple of weeks ago in your presentation, but again, since we're talking about ventilation, the importance of pressures and everything, in some of our older machines, how do we go about measuring inside those machines to make sure we've got the right pressures? And how much of our hallway and plenum pressures affect those pressures? You talked about it a little bit a couple weeks ago. They don't go into too much depth, but briefly, can you cover?
Mm-hmm. Well, like you said, I would suggest that they go look at our previous presentation on how to take pressures inside the cabinet. Typically what I see is when I do the total pressure of the cabinet, if that hallway is running a negative pressure, when I take the total pressure, which is the tube inserted in a multi-stage underneath the first rack of eggs, the total pressure of the cabinet will be less, because it's being robbed of air, and can't build the pressure it needs within the cabinet. The other thing that I see, if it's overpressurized within that hallway, then when I take that reading, Then when I take the hallway reading, it influences the cabinet pressure within the cabinet of our 60-40 ratio that we're trying to obtain. So a lot of times, if I'm called upon to go in and do a service visit in a multi-stage hatchery, if the ventilation is not correct, then there's not a whole lot we can do. You know, we can look at the Band-Aids you already have in place, and usually it's very difficult to help you. But when that ventilation is right, we can sure get the most out of that multi-stage equipment.
Yeah, and you talk about the Band-Aids. Sometimes we see some interesting Band-Aids to where it's like, well, we just don't close our hallway doors because we can't maintain pressure, but this seems to work. Well, again, your machines are going to try and compensate and work as well as they can, but if you're having to Band-Aid things, they're not working optimally. I mean, that's just the bottom line.
Not optimized, that's for sure.
Yeah, we talked a lot about ventilation in the hatchery setters, hallways, plenums, everything. What about in the egg storage room? What type of ventilation do you think we need there, and how much of an impact can that have on overall hatchability?
Well, we need to have a ventilation system large enough to keep that room at our egg room set points. And so usually these are, I've seen both, I've actually seen some of these direct flow 100% in the egg room. Fresh air is, I'll just say, is not as critical. We do need to have some air exchange. Of course, you know, we have employees working in there, but we also need to maintain humidity within that room. So ventilation within an egg room, we need to maintain temperature and humidity, and need to have a system adequate enough to keep that room at its at a set point 65 or whatever throughout that room, but consistently dispersed throughout the room.
Yeah, we want to control the hot and cool spots like you're talking about. We need to have enough ventilation to have uniform air conditions and environmental conditions.
And that's simple enough to check with a digital thermometer, you know, just reading top to bottom. Some hatcheries install ceiling fans to mix. Very cheap way to get that air mixed up really good for you.
Okay. All right. Well, a lot of good questions, Philip, and we do have quite a few more here, and we're not going to be able to get to all those. But if those that we didn't get to, we'll try and get answered directly in an email to you or in a written form. Submit those again, and any other questions you might have after this. So again, appreciate very much, Philip. Appreciate all you for attending. We had a pretty good crowd here, a lot of different companies represented on our attendee list. So I hope you enjoyed it. And thank you again, Philip, and look for you next week. We have vaccination in the hatchery with a guest lecturer coming in, and I think that'll be good as well. So thank you all again for attending, and hope we see you again at future webinar Wednesdays. Bye.
Bye.